Every email you send, every video you stream, and every file stored in the cloud exists somewhere physically. Behind the internet is a network of buildings filled with servers, electrical infrastructure, and cooling systems working continuously to keep data moving. These buildings are called data centers. In this video series, we are going to explain how data centers actually work from a mechanical and electrical perspective, focusing on the systems that keep servers powered, cooled, and operating without interruption. This first video provides the big picture overview. We will explain what a data center does, why these facilities consume so much energy, and why mechanical and electrical systems are the most critical part of the building. In the following videos, we will begin breaking down each system in greater detail. At its simplest level, a data center is a facility designed to store, process, and distribute digital information. Inside the building are rows of servers, which are specialized computers responsible for storage, computing, and network traffic. Unlike office computers that operate intermittently, servers operate continuously. They run 24 hours a day, every day of the year. This creates an important reality. Servers consume large amounts of electricity, and nearly all of that electrical energy eventually becomes heat. While most people think of data centers as IT facilities, from an engineering perspective, they are really energy conversion buildings. Electricity goes in, computing work is performed, and heat comes out. The entire facility exists to manage that process safely and reliably. Every data center, regardless of size, must solve three fundamental problems. The first is continuous power. Servers cannot simply shut down when power is lost. Even brief interruptions can cause data loss or service outages, affecting thousands or even millions of users. As a result, power systems must remain available even when equipment fails or utility power is interrupted. The second problem is continuous cooling. Because servers generate heat constantly, cooling systems must also operate continuously. If cooling stops, temperatures can rise quickly, forcing equipment to reduce performance or shut down to protect itself. Cooling in a data center is not about comfort. It is about equipment survival. The third problem is continuous operation. Data centers are designed for uptime. Maintenance, equipment failures, and repairs must occur without interrupting operation. This requirement is what drives the heavy use of redundancy throughout both mechanical and electrical systems. There are various levels of redundancy and industry tier classifications used to describe reliability and uptime expectations, and those concepts will be covered in a later video in this series. Although data centers appear complex, most of the infrastructure falls into three major system groups. The first group is electrical systems. Electrical infrastructure brings power into the building and distributes it safely to server equipment. This includes utility connections, switchgear, backup power systems, and power distribution equipment. The goal is simple. Power must always be available. The second group is mechanical cooling systems. Mechanical systems remove the heat generated by servers. Depending on the facility, this may include chillers, cooling towers, pumps, air handling units, or specialized cooling equipment located directly at the server racks. The objective is to keep equipment operating within safe temperature ranges at all times. The third group is controls and monitoring systems. Controls tie electrical and mechanical systems together into one operating environment. These systems monitor temperatures, power usage, equipment status, and alarms, allowing the facility to automatically respond to changing conditions or equipment failures. In modern data centers, controls and monitoring are just as important as the physical equipment itself. Data centers are often misunderstood because they look similar to commercial buildings from the outside, but operationally they are very different. In an office building, occupancy changes throughout the day, cooling loads rise and fall, and equipment cycles on and off. In a data center, electrical loads are constant, cooling demand is continuous, and systems rarely shut down. Failure tolerance is also very different. A comfort cooling failure in an office building creates discomfort. A cooling or power failure in a data center can create immediate operational risk. Because of this, data centers typically include redundant equipment, multiple power paths, and system designs that allow maintenance without shutting the facility down. Now that the big picture has been established, the next step is understanding how energy actually moves through a data center. In the next video, we will walk step by step through the electrical side of the facility, following power from the utility connection all the way to the server rack. After that, we will cover how heat is removed, how airflow is managed, and why redundancy drives nearly every design decision in modern data centers. Understanding this foundation makes the rest of the systems much easier to follow and provides the context needed to understand why data centers are designed and constructed the way they are. If you found this video helpful, be sure to check out our HVAC and plumbing estimating spreadsheets to streamline your construction bidding process. Check out our HVAC, electrical, and plumbing construction forms to help you run your business, and explore our online courses for in-depth training.